In this problem, we have a series of logarithmic equations. Our task will be to change these logarithmic equations to exponential form. In our first problem, we have log base 2 of 32, which is a logarithmic equation. Since we have a log base 2, our first step, if we wish to change to exponential form, is to take a base 2 exponential on both sides. Therefore, we will write 2 on the left side, an equal sign, and then 2 on the right side. We'll take this log base 2 of 32 and move it into the exponent on the left. Therefore, we'll have 2 raised to log base 2 of 32. The entire left side becomes the new exponent on the left. We can do the same to the 5 on the right. We'll move it into the exponent on the right, and we'll have 2 to the 5th power on the right. Now, from the previous video, we said that if you have a base 2 exponential connected to a log base 2, those are inverse functions. Because they are inverse functions, we may cancel them. We cross out the base 2 exponential and cross out the log base 2, and so all that remains is the 32. We'll write that on the left. Then on the right, we'll keep that 2 to the 5th. Therefore, our exponential form of our equation is 32 equals 2 to the 5th. You can see that we don't have a log anymore, and we have now only an exponential and a constant. We can repeat this process for log base 6 of 216. We'll start by writing a 6 on the left and the right. All of the items that are on the left become the exponent on the left, and so we'll have 6 raised to log base 6 of 216. On the right, the 3 becomes our new exponent, and so we'll have 6 to the 3rd. Now, remember that base 6 exponential and log base 6 are inverse functions, so we'll cross both of those out, and this will leave only the 216. We'll bring that 216 down. It will stay on the left. And on the right, we will now have 6 to the 3rd. This gives us the exponential form. So in order to get into exponential form, we use an exponential that has a base that matches the log we started with. Let's now do an example with common log. Here we have common log of 100 equals 2. Now remember that a common log is a log with a base of 10. You can tell you have a common log if no base is written, but we will treat it as base 10. Therefore, we'll use a base 10 exponential on both sides. We'll begin by writing 10 on the left and right. The log 100 will come down and become our new exponent on the left side. On the right, the 2 will come down and become our exponent on the right. Now, we have a base 10 exponential with a common log. A base 10 exponential and a common log are inverse functions. Because those are inverse functions, we can cross out the base of 10, and we can cross out the common log, leaving us with only 100 on the left side. On the right, we still have 10 to the 2nd power. This will be our rewritten form of the common log. Make sure that you have a base of 10 when you use common log. For our final question in this set, we'll look at natural log, or ln of 2 is approximately 0.693. A natural log is base lowercase e, or Euler's constant. Therefore, we will use a base e exponential. Therefore, on the left, we'll put lowercase e, and on the right, we'll also put lowercase e. The ln of 2 becomes our new exponent on the left, and the 0.693 becomes our exponent on the right. But lowercase e and ln are inverse functions. If you have a base e and a natural log, those functions are inverse and cancel each other out. Since they're inverse functions, the e cancels out with the ln. Both of them will go away and leave behind the number 2. This will give us a 2 on the left and an e raised to 0.693 on the right. This is the exponential form of that original logarithmic equation. So the key to rewriting things in exponential form from logarithmic form is just to pick the right base and cancel out the inverse functions.